Okay, it looks like we are live. How's sound? Okay, looks like it's picking it up. Awesome. Welcome everyone to the Timescale Twitch stream. Today we are kind of just going to be continuing looking at NFL data. And so that's primarily what we're going to be doing today. So if you were able to catch the last stream, we were just kind of like introducing this NFL data set, kind of getting more of the basic structure of it, kind of like understanding it, and doing some basic queries, things like that. And in this stream, this is just kind of picking up exactly where we left off. So we're going to continue with some more advanced queries, but I'll get into that in the agenda. But if you are new, if you did not see the last stream or catch it on YouTube or Twitch or wherever, definitely check it out. You will have lots of good context through it. And yeah, let's jump in. So this is the agenda for today. So first off, we're just going to briefly recap on the data set, just to kind of jog everyone's memory, right? It's been 2 weeks. So, I mean, if you're like me, I forget a lot of things like after a day, sometimes even an hour. So just like a quick recap of the data set. Then we're going to briefly discuss some of the queries that we talked about last time. And then we're going to run some more advanced queries, again, kind of picking up where we left off. And, oh, it sounds like you may not be able to hear me on Twitch. Can someone confirm whether or not you can hear me? Okay, so the volume needs to be up a little bit more. Okay, how is this? Is this a better volume for everyone? Thoughts? Okay, awesome. Yes, it is better. Cool. Thank you for calling that out. Awesome. I think I turned down the volume, so that's my bad. Did a personal stream the other day with art, and so I think I must have turned it down. Okay, so back to the agenda. So recap the data. 2, we're going to go through just talking about the queries that we did last time. 3, we're going to do some more advanced queries, and this is kind of what we couldn't get to last time. And then later on in the stream, we are actually going to be doing more continuous aggregates. And this time, we're actually going to be utilizing some hyperfunctionality. You choose, I don't know. So we're going to be looking at that and kind of like the 2-step aggregation method that we use at Timescale, which also is utilized in Postgres functions as well. And we'll, talk more about that after, like on step 4. Step 5, we're going to just look at, briefly some of the really cool functionality that you can get by creating continuous aggregates kind of with utilizing like the aggregate part of our 2-step aggregation functions. And again, that's a lot of like words, so it's okay if you don't understand it all right now. We will get there. Slow down. So then after that, we're going to do a wrap up and see you guys off. So let's get rolling. So recap on the data set. I am going to switch over to dbeaver now. Woohoo! So the dbeaver, again, if you couldn't join last time or if you're new to the Timescale Twitch stream, a lot of us use this tool. It's essentially like a GUI that works on top of Postgres or actually I think there's like all kinds of databases that you could pull into it. Anyways, it's a great tool, especially if you're a visual person like I am. I really appreciate getting to kind of see the table layout and see all these kind of like the structure. But, you know, if you love command line and doing Postgres with command line, like power to you, you keep doing it. But this is the tool that I'm going to be using today. So dbeaver, cool tool. So let's recap on the data set. So this data set was provided by the NFL for their Big Data Bowl, their 2021 Big Data Bowl. And essentially, the Data Bowl, their goal was to have, it was a Kaggle competition. Again, just refreshing our minds. It was a Kaggle competition that encouraged data analysts or anyone to essentially analyze their passing play data and see if they could do like predictions on it, things like that. Well, unfortunately, that means that our data set, at least the play table, only includes information on passing plays. So, you know, there's not kind of information on like tackles or like other types of plays. So it's really kind of looking at passing plays. However, right, the tracking table, if you remember, is tracking players' movements, position, acceleration, distance traveled, orientation, direction, like all of that in a quarter second intervals. So we have like four readings per second for like players and the ball for every game in the season, in 2018 season. So this is a lot of data. So the tracking table has tons of data that even though, right, we just have passing play information in the play table, you can still glean a ton of information off of the tracking table alone. So, you know, just refreshing it, keeping it in our minds, right? Those are just some of the caveats that it's passing play, and it's also from the 2018 NFL season. But still, there's tons of really useful data here, and so that's why, right, we want to analyze it. And remember this, so last time we talked about how they essentially collected this data by using RFID tags on the players and the football. So you can kind of think of it as an IoT data set, really. And so this is time series data, right? We have a time column that is pulling in tons of this time series data. So our little refresher and recap, super useful. So now, right, we refamiliarized ourselves, but what about the queries from last time, right? Let's just refresh on those as well. So last time we talked about, we had a continuous aggregate that we made, and that was very useful. It really sped up our queries. We were able to run a lot of things much quicker, if you remember, by using continuous aggregates. But most of our queries from last time were on a by game basis, right? So we were aggregating data, mostly distance traveled data, right? We were summing it over an entire game, which is useful, right? It's going to be very helpful in kind of understanding kind of like the general, maybe some general statistics on the games themselves, like, you know, what player ran the most on average during a game. But right, that, you know, that can only give us so much information, right? It's on a per game basis, so it's not very granular. And so kind of today, I wanted to talk more, I wanted to like dig in more, you know, dig into, right, we did a game by game basis, but what about like minute by minute? You know, like how can we analyze even further, deep dive even further into the data and get even more useful information out of it? And so, right, if we were to, now that we're kind of looking at a more granular, you know, amount of data, that means that you could potentially, extrapolate this to analyzing plays, right? Because plays, you can actually look at a play that happened over, a certain number of minutes and look at like data that's specific to that play, right? So you can essentially, my hope is to kind of build up some more background in kind of like more advanced queries and some continuous aggregates, so that you could analyze further, you could dive further. So that's kind of the goal here today, and a recap on last time. So, all right, let's jump in and run some queries. And so these are the more advanced queries that we couldn't get to last time. So what I'm going to do is hop back over to dbeaver. And, okay, so we have our lovely tracking table displayed. So what I'm going to do is open a new SQL console, and I'm just going to grab my script. So one of the questions that I had that was kind of like a more complicated question is, how many plays did an individual participate in when they were on the defensive and the pass was not completed? Because in my mind, right, if a pass was not completed and you were on the defensive, right, that's a good thing. I'm curious to know, how many plays were certain individuals involved in when they were on the defensive, and the pass was able to be stopped, right, to prevent the offensive from either gaining yards or whatever, maybe even a touchdown. So that was kind of my question that really drove this query. And before we can really jump into that, I wanted us to kind of go back to the play data and think about how would we even come up with this query, right? Because again, a lot of today and last time, I wanted to encourage you, anyone who's listening right now, like ways that you could kind of do some of your analysis within the database and by using Postgres and Timescale functionality. And so part of that, right, part of the analysis process is kind of understanding, like having these questions and figuring out, how do I get from point A to point B? I have this question, I want to know this information, how do I get there? And so a lot of that, right, is going through the data and really understanding, how do we get that information? So initially, if we look at the play table, right, because we want to know the number of plays that a defensive player is involved in. If I want to know the possessive team, that's important information, right? I need to know whether they are on the offensive or on the defensive. So I need to know who's in possession of the ball for a certain play. So, right, if I look at this play, just as an example, right, we see that we have, description on this, and we have the possessive team identified. Okay, so we have that, so we're definitely going to have to use that, right? We're definitely going to have to somehow link to this column, right? And then we also have, right, we want to know the outcome of the pass. And so we see pass result here. So we have complete, incomplete, S is sacked. There are a few others in here that you could filter on if you want. But yeah, so we have pass results, so that's going to be important as well, right? Now, if I look at the tracking data, which gives us, by player information, per game, right? So we have, let's look at this row and kind of, refamiliarize ourselves. So we have, right, the display name, we have the player ID, we have the game ID and play ID. So that's, right, how we're going to identify, okay, this player was involved in this play at this time for this game, right? So we need all these columns. Now, this is where it gets a little bit interesting and kind of where you have to, think, how can you play around with logic in logical statements in Postgres to kind of get the information we need, right? So this table doesn't actually give us the team abbreviation that this player is associated with, right? So if we look at the play table again, the possession team identification is using the abbreviation of the team, right? But tracking is just using home, away, a binary option to identify if they're, on the home team or the away team. So somehow, right, we need to map this player to their team in order so that we can see, were they defensive or were they offensive? So that's kind of like, the conundrum now that we kind of have to untangle, right? So if we go to this query, essentially that's what we're going to do with this query here. And so if you remember from last time, we used CTEs pretty often to kind of like set up kind of like a, table-like object that then we can pull from in another query. And so that can be often helpful. However, if you, have CTEs that you're using again and again and again, you can always create a materialized view. And that's another Postgres function, functionality that can be really helpful. I'm not going to do that today, right now, because, right, I'm just kind of going to be using this twice. So I'm just going to keep it as a CTE. So if we look at this kind of like first step in our query, we have the player ID, so that's important, right? We want to know who the player is, right? We need play by player information. We want their name to be displayed because, right, we have no idea who player, ID 13592 is. I don't know. So we need to display their name. That's important. Event, if we look back at the tracking table, there is an event column, and this event column essentially kind of gives you a snapshot of did something happen during that frame or time period. And so there are different event tags that have snap in them. And so, right, this is, we want to kind of parse it down to just snap plays. So that is kind of like the event, and you'll see that we have snap here. We'll get there though. Then we have the game ID, right? That's to allow us to identify per game and play ID basis. So that kind of helps us uniquely identify a play, an individual play. So then this is kind of where things get interesting, right? We need to tie, remember that the tracking data only has home and away. So somehow we need to tie home and away to the that individual's actual team's abbreviation. So how we're going to do that is by using case. And so if you are familiar with like any typical programming language or just even in logic courses, right? Case is something that you've probably heard before. Like setting a case when X happens versus a case when Y happens, setting the output to be different. And so that's exactly what we're doing here with Postgres, is that we're setting up a case so that essentially we can rewrite that team column to give us the information that we want, right? Because we don't want away and home. That doesn't help us. We can't tie it then to the play table. So what we're going to do is map, essentially, so when the team identification is away, then we want to show the visitor team abbreviation from the game table. So now we're pulling in the game table. All right, let's go look at it. So if we go to the game table, we see that we have game ID, which is important, game date, time zone type stuff. And then we have home team and visitor team identifications. And then we actually have the abbreviation for those teams, okay? So what we're doing is we are saying that if the team is away, then I'm going to go to the game table and grab the away team abbreviation and insert it into this column. And when the team is home, right, we're going to grab the home team abbreviation. So you can see, right, we're kind of mapping away and home to their abbreviations here. And then the else case for null, right, if you remember, we have football data in our tracking table, and the football data reads as null in a lot of things, right? Football is not on a specific team. Be interesting if it was. Fascinating. But right, so if for all other cases, right, mostly just the football, we can just say, you know, keep it as null. That's cool. That's fine. And then we're going to end our case kind of identification statement and rename it as team name. Cool. So then, and then we also include position here. So, right, we're taking from the tracking table, we're joining on the game table to get the visitor team home abbreviations. And then this statement is essentially, right, if you remember, tracking data has millions of rows of data. It's a lot of data. And so what I want to do is essentially pare that down to the data that only applies to what I need, right? Because it, you know, joining on, you know, other tables later could slow things down if we have all the data. So, you know, might as well just parse it down now. So that's kind of what this does. And for people that are newer to kind of SQL syntax or Postgres syntax, right, this, the percents here are essentially saying, I don't care what's before or after snap in, right, for this event column. I don't care what is in this string that's identifying what happened. I don't care what's before or after snap. I just want to know when it includes snap. So that's kind of what this, the percent signs do there, is that it, you know, allows us to identify anything with snap in the string. So I'm going to run this, you know, this CTE first, just, you know, to give us a picture. So right, we have the player ID, we have their name, we have the event, right? It has snap in the string, so it correctly pared it down for us. We have the game ID, play ID, and now we have team name. So now we can actually map this player to this specific team. And I can have their position as well in case you want to filter it by position, even if you're interested. But that's for later on. So now that we have a player, a game ID, and a play ID associated to a team abbreviation, right? Now I can join on that play table, excuse me, and pair out, right? I can say, you know, who is the possessive and not like defensive or offensive team for that specific play, and kind of filter it out. So that's right. I'm gonna scoot over to the next part of our query here. So right, we're pulling from snap plays, and that's the name of our CTE up here. Here, I'll make this a little bit larger. So snap plays, I'm pulling from this snap plays table, right? So I'm going to take the player ID, display name, cool. I'm joining it on the play table, right, on game ID and play ID to uniquely identify each ID, play ID, where the team name is not possessive, not the possessive team, right? So if you have possession, then, right, your offense. If you don't have possession, your defense, right? So we don't want the possession team. And we also don't want where the pass result is completed, right? Because I want to know when it's not completed. All the cases when it failed, essentially. So then I'm going to count the events that happen. So, right, I'm counting the number of rows, essentially, that are associated with this, certain pass result and player. So that's kind of the play count. Then I also decided to include team name because that can be helpful, right, if you want to know what team they're on. And then their position, say if you wanted to know, like, for quarterbacks specifically, how many plays were they involved in, you could put a where clause to kind of pare that down even more. But yeah, so that's kind of the gist of this. So if we run this in whole, okay, so now let's look at our results. So we have player ID, 𝗥𝗲𝗹𝗲𝗃, I'm probably not pronouncing it. Isn't Weedle a Pokemon? Anyways. Weddle. I'm going to say Weddle. That's probably right. I'm taking the play count, right? So 235 plays that 𝗥𝗲𝗹𝗲𝗃 was involved in when he was on the team. I'm guessing this is Baltimore. I don't know. I could be wrong there. Don't quote me on that. His position for those games, and what was the pass result. So he was involved in 235 plays while he was on the defensive, and the pass result was incomplete. So, right, and there's tons, you can look at whichever player, and you can look at different pass results, right? You don't only have to look at you could specify it to, maybe if you wanted to know sacked pass results specifically, you could look at, who was on the defensive, and then you could even look at, pare it down further and look at, who was maybe on the position that could have been involved in helping the sacked pass or whatever. So you could see how this, you could filter this out more and more and see, which players were consistently performing and consistently helping out on the defensive to prevent the offensive from, gaining yards or scoring points or whatever, right? That might be really useful in understanding, like, which player is valuable. Who do you want playing when, you have, if you're on the defensive, if you, like, which player would be best for that, position. Anyways. So you could see how you really could extrapolate this quite a bit. Now, what about the flip side, though? What about if you're on the offensive and the pass is completed, right? Maybe you want to know, which players, let's paste this in there, which players were on the offense and were successful in their pass result. Right, that could be equally as interesting and helpful in, like, who is helping out to complete a pass on the offensive, right? So essentially, it's the same query, basically, except this time, instead of saying where it's not the possessive, we want to know when it's the possessive team, when it matches on the possessive team, and when the pass result is complete. So if I run this, right, it's essentially the same thing, but we just, tweaked it a little bit, and we can get kind of the opposite story. And if you look, right, Ben Roethlisberger, I struggle saying his last name, TBH, which is sad because I'm in Pennsylvania and, like, a lot of my family is from Pittsburgh. Sorry, Ben. Hopefully I pronounce it okay. Anyways, right, if we look at the play count, 456 plays that he was involved in where the pass result was complete. That's pretty impressive, you know, like that's a solid amount of plays that he helped complete. And again, you can look at position, like maybe you want to look at, you know, quarterbacks specifically. You could see which quarterbacks tend to be involved in like the highest number of plays that are successful. Who knows? So again, this is potentially very useful information. And it just kind of digs deeper into like a play-by-play basis. You know, how much more information you can glean and kind of get from this data set, you know, by digging in, you know, more and more. So, cool beans. Those are some more advanced queries. Now, let's get even more complicated. Woo! So, next we're going to be jumping into more complex continuous aggregates. So if you remember last time, right, we did aggregates over one day. What if you want to do aggregates over 1 minute? Right? Minute by minute basis, like information could be super useful. You could figure out, you know, stats on maybe specific plays, like what was the, you know, max acceleration or the average acceleration over a specific play for the players involved, right? You can get really granular with 1 minute, which is awesome. Now, so let's switch back to dbeaver. Okay. So, just pulling up. So, I'm going to show you 2 potential continuous aggregate queries. And I'm going to do this because I'll explain, you know, kind of, yeah, I'll explain this. So, first off, this is kind of the first query that I want to show you. So we could totally use this. No problem. This would, you know, like super helpful. You know, we have player ID, game ID, play ID. And then we're going to bucket it by minute, right? With our time bucket function. And then we can do the average of the distance. So that's the average distance being recorded per, you know, quarter second over a 1 minute period. So, you know, an individual's average distance, the sum of the distance, right? We could take the average acceleration over that minute, max acceleration, min acceleration from tracking, T, and then group by. This is a totally legitimate option, right? But what if later on you want to get, instead of 1 minute intervals, what if you want 5 minute intervals or 10 minute intervals? Well, taking the average of an average doesn't actually give you the true average. And there are a few cases where some aggregates, right, if you calculate them in the continuous aggregate over that bucketed minute, it may give you different, and you wanted to, you know, aggregate it again over 5 minutes. Some of those aggregations will not give you the true answers if you were to look at all the raw data. So what you can do is actually utilize our hyperfunction, our 2-step aggregation hyperfunctions. And essentially they're built using these two type of objects, which are called UDD sketch and tdigest, which again, these are random words for you guys, but we'll jump, you know, I will explain them, so don't worry. We essentially use these objects to help us kind of roll up time without losing accuracy. And I'll show you guys, because right, again, I'm a very visual person, so it helps to see these things rather than just hear them said. So, I didn't actually grab the other one. Okay, so what we can do is create a different continuous aggregate that essentially just gives us more freedom to calculate more things. And so that's by utilizing this 𝑢𝑑𝑑_sketch and tdigest options, right, structures. And then I'm also actually going to do the sum as well, because, right, sum you can do across like multiple aggregation levels, and you can take the sum of these numbers and then the sum of those, like you wanted to re-aggregate over another area of time, and you could sum those, right? Sums will always work. But things like mean, percentile, there are other things that it gets a little bit more complicated, right? So essentially what I'm doing here is creating a 𝑢𝑑𝑑_sketch for our distance and a tdigest for our distance and also for acceleration, and then our sum. And again, I'm going to show you, we're going to dive into this more, so don't worry if this doesn't make total sense right now. So I'm going to go ahead and let this run. It's going to take a little bit of time, right, because we are creating this continuous aggregate per minute, so it's pretty granular, so it might just take a little bit of time to run. So while it does that, I'm actually going to hop over to Chrome, hop over to our docs, really, and kind of refresh you guys on hyperfunctions and this two-step aggregation, and hopefully this 𝑢𝑑𝑑_sketch and tdigest stuff will make a little bit more sense. So let's hop on over. So okay, if you have not checked out the Hyperfunction blog post series by David Cohn, it's excellent, and it explains this stuff really, really well. So if you're feeling lost, don't worry. It's a lot of kind of more advanced techniques. And so definitely take the time if you're interested in hyperfunctions and using the two-step aggregation. Check out the blog series. It's super cool. And our docs, also super useful. So essentially, right, we have all these different percentile approximation and like hyperfunctions that we could use. So like mean, for example, which would calculate the mean of, a set of numbers, right? Essentially, in the two-step aggregation method, it takes in a 𝑢𝑑𝑑_sketch or tdigest object and applies this accessor function on it to give us the output. And so we actually used the approximate percentile hyperfunction in our previous Twitch session. And to jog your memory, we can actually go back to dbeaver, and this aggregate is done running. So I'm going to pull up our query from last time to kind of show this to you guys again. So right, last time we calculated percentiles, all these different percentiles, and the min vals and the max vals, mean and stuff, using our hyperfunctions and this like aggregate accessor function combination. And essentially, to recap, we use this aggregate function percentile ag to do kind of the heavy lifting work, right? And then this accessor function approx percentile we applied to the aggregate function, okay? And UDD_sketch and tdigest essentially are just, I mean, it's like the same thing as this percentile ag, but it gives you a little bit more control over possible error and things like that. And so with our continuous aggregate that we just created with the new CAG setup, paste it here just for comparison. So this UDD_sketch essentially is just replacing this percentile ag. And what it allows us to do is that we kind of set up the heavy lifting aggregate work in our continuous aggregate, which then afterwards we can apply any accessor function to that output on our continuous aggregate. And it can be really useful if you want more flexibility in what kind of information you want to grab out of your continuous aggregate. Say that you set up a continuous aggregate that uses the average, right, and sum, but it doesn't utilize percentile ag, this percentile ag, and you want to know the percentile, you want to calculate the approx percentile off of the continuous aggregate. Well, if you kind of insert the UDD_sketch and tdigest object, or even percentile ag, you could also do percentile ag of dis here if you wanted, in your continuous aggregate. By doing it in the continuous aggregate, it gives you freedom to use anything afterwards, any of the accessor functions afterwards, which can be really helpful. It also allows you to do rollups, which I'm going to go over 2 examples today. And again, this is just kind of scratching the surface of kind of the potential that you can unlock with using hyperfunctions in this 2-step aggregation method. There will be more blog posts and Twitch streams in the future to kind of like go through this, more examples and go through more detail. So this is just kind of like getting you familiar with it, playing around with it. So don't worry if it's kind of like heavy right now. So now actually we can jump in to our next session, or our next section, right? We created the more complex continuous aggregate. Now let's actually see the power and how to use these UDD_sketch and tdigest objects to, get information. How do we actually use these objects? So going back to dbeaver, okay. So let's look at how do we actually use these. Okay. I'll get there. So what if we wanted to ask the question, what is the fastest acceleration in a specific minute of a game by a single player? So I want to know, like, on a per player basis, what is the fastest acceleration that they had over one specific minute. So using our aggregate, our new continuous aggregate, and I named our new continuous aggregate is that minute CAG data. That's the name of the continuous aggregate that we just created. What I can do is, right, since I have the tdigest object in our continuous aggregate for acceleration and distance, if I want to know the max value, which is a hyperfunction, all I need to do is just apply that hyperfunction, that accessor function, to the inner aggregate, which is the heavy lifting work, that a digest, and that will give me back the information I need. And so I'm actually going to hop back over to Chrome to kind of show you. We have many different aggregate or accessor function options that you can use kind of on these tdigest and udd_sketch objects. And so, right, approximate percentile is one that you can apply to a udd_sketch object. Approximate percentile rank, that's another accessor function that you can apply to it. Error, rollup, mean, number of values, min value, and max value. And so, again, by creating a continuous aggregate with just the udd_sketch and tdigest information, I have the freedom then afterwards to say, oh, okay, well, actually I want to know the max val per bucket. And, oh, I also want to know the min val per bucket. And I want to know the mean as well. And maybe the median or the 75th percentile. You know, you can do all that afterwards. So it just gives you more freedom. And we'll talk about rollup next, which is also very useful, especially if you want to like change, you know, not just work on 1 minute, but maybe 5 minutes, but we'll get there. I'm getting ahead of myself. So let's switch back to dbeaver. So essentially, right, I'm applying this accessor function on our acceleration tdigest object, right? Okay. I'm going to grab the player ID, and I'm joining on the player table. We actually, I don't think we even use this. No, we do not. We do not. Can delete that. Perfect. So I'm getting the player ID. I'm getting the display name. So I joined on the player table to grab the display name, right, from our continuous aggregate. And then I want to order it by max val. So if I run this, ooh, I just ran this. Wait, did I need this? Okay. I didn't think I think maybe I highlighted something weird. Okay. Anyways, we'll just leave it. We'll just leave. Ask whether this can. Yes, okay. I must have just highlighted something weird. Mini heart attack. So if we look at this, if we look at the output, right, we're getting all these nulls again, which makes sense, right? We're looking at the maximum acceleration of a player ID over like a 1 minute period. So of course, if we remember, right, the player ID and display name that is null is the football. So it makes a lot of sense that if we're looking at 1 minute time buckets, you know, the football is going to have some of the highest acceleration. Honestly, it's shocking to me that Mark Ingram was able to have faster acceleration in a 1 minute period than the football. That's fascinating. And also something that you could then kind of look into and say, what was he doing that like he was able to be so fast, right? But right, I don't really need to know about the football. So what I'm going to do is actually put in a where statement where, let's do player ID is not null. Okay. That just kind of filters out the null. Oh, right. Has to be unique. Uniqueness. Okay. And also notice that was really fast. Super fast. So I can get minute by minute information very quickly. Again, with continuous aggregates, and then with the hyperfunction, like the accessor function that I can apply, it gives me more freedom to get, you know, stats and things that maybe I didn't think of initially when creating the continuous aggregate. So, right, we can look at this and like we now get the maximum acceleration over a 1 minute period, you know, over a single 1 minute period. Some impressive numbers, right? You might want to look into these players specifically and see like, oh, what was happening there. So super cool. And then real quick, because we are very close to the end of our session, let's look at the rollup functionality and the rollup capabilities of, which again is another reason to include these UDD sketch and tdigest objects in your continuous aggregates, is for kind of these rollup capabilities. So say that you, we have a 1 minute period information, but let's say that I have the question of, what is the mean and median acceleration by one player over a 5 minute period, right? Now, I don't want to know just about 1 minute. I want to know about 5 minutes. Now, with rollup, we're able to easily utilize our continuous aggregate and get this information, which otherwise we would have to, kind of bucket things. And so, okay, so here, right, I get the game ID, the player ID, and their display name, because I want to know, right, on a 5 minute basis, what is a player's mean and median acceleration over a 5 minute period, okay? Taking it from our continuous aggregate. So this time bucket essentially just says, okay, instead of 1 minute, we're going to bucket it by 5 minutes, okay? And then all I need to do is just add rollup to our UDD sketch acceleration object. And now the mean will be calculated on the on a 5 minute basis rather than a 1 minute basis. Okay, same thing with the median. It will essentially, this rollup function creates almost like a new aggregate from our old UDD sketch aggregate function. Now it's instead of having 1 minute, it's including 5 minutes, right? And so you get kind of more accurate information depending on the accessor function that's applied. Again, an average of an average is going to be different than an average of the original raw data. So essentially this rollup allows us to get the mean or average of like the raw data as opposed to the, taking the mean of the raw data, if that makes sense. So this rollup function is super useful for that. And so if I run this, again, it takes a little bit of time, but we're going from 1 minute to 5 minutes, right? It's, it makes sense that it takes a little bit of time. But now, right, we have game ID, player ID, their name, the time bucket, and then the mean and median for that player at that time bucket. So, right, these are 5 minute periods. So, in this 5 minute chunk, Zeke Turner's mean acceleration was this, and median acceleration was this. And this is off of the raw data. So again, using the UDD sketch and tdigest objects within the continuous aggregates just give you the freedom to kind of afterwards change things around, right? You can kind of change the time bucket and still have access to kind of that raw data image, which can be really helpful in analysis instead of having to take, an average of an average. And who knows, maybe you end up doing way more, 3 averages on top of each other. I don't know. And just for a quick comparison, because I know that we're basically at the end of our session today, time-wise, the difference is pretty substantial. So if you had a continuous aggregate of 1 minute and you wanted to, know the average without doing, an average of an average, right, you would have to run it on the original raw data. And so the kind of equivalent query would be this, right? You have to do it back on the tracking data to get the true average acceleration of the raw data. And, you know, this query that we ran with our kind of utilizing the two-step aggregation method of our hyperfunctions, right? That took 11 seconds around. And just for comparison, you know, let's run this, right? And you can see that, again, by kind of using these timescale functions, you can really cut down the potential time that you otherwise would take kind of doing analysis on the data. And, you know, saving time is always going to be a win, right? You can always get more done. The less time that you have to wait, you sitting around, you can get way more done on other things. So, right, that took 33 seconds. So you can see, like, that's just, you know, it's a third of the time, you know, by kind of utilizing our hyperfunction two-step aggregation. So again, this is just kind of an introduction to using hyperfunctions and rollups and kind of more continuous aggregates for analyzing your data and for analysis. I will actually be doing I'll be working on a blog post series kind of talking about how you can do kind of your data munging within the database directly, and, you know, instead of kind of pulling something into like Python or something and potentially running into inefficient kind of queries by, you know, doing all of your data munging within Python. You can essentially do a lot of that stuff in your TimescaleDB database directly, kind of with these hyperfunctions and with this two-step aggregation. And again, like, there's a lot of content coming kind of through the pipeline that will talk more about this. And this is just kind of, you know, just scratching the surface and showing you the potential power of using this stuff. So go back to the PowerPoint. Yeah, that's pretty much it. That's the wrap up. We did some more complex analysis today. Super fun. We dug in a little bit with hyperfunctions and rollups and all that fun stuff. Yeah, join us next time. We do streams every Wednesday. Also, I think I keep forgetting to introduce myself, so I guess I'll just do it at the end. I'm Miranda All, and I am a developer advocate for Timescale. Thank you guys so much for coming, those of you that could make it, and thank you for watching it if you watch it, the recorded versions on YouTube and Twitch. Also, we will be including links for hyperfunctions and like the blog post on hyperfunctions and the docs. So definitely check that out. Also, I think we'll have links for the dataset and our tutorial on how to import it yourself, and kind of get started with analyzing all that stuff. Yeah, and that's all, folks. Have a wonderful Wednesday, and see you next time.